Hi everyone, we are going to walk through the solution to the calculate beta application. I've updated the file with additional comments, so make sure you go get the updated Excel file. And specifically, we're going to focus on these 5 main tasks. We're going to see how we can set up reference to solver by going to tools. Tools is, well, it's in VBA. References and then solver, and then we'll come back to the model worksheet. The model worksheet's over here to set up solver on the model worksheet. So if you don't see these tabs, that's because they're hidden. You can always unhide them by just right-clicking the tab, any of the tabs, and go to unhide and select the ones that you want to unhide. You can see that they're a bunch, they're hidden. They're hidden or visible at different times, different points of the program. And so you may see different number of tabs at different stages of running the program. If you end the program prematurely, like in the middle of debugging, like what I was doing, you will see some of these tabs, not all of them. So most of them are hidden when the program started. You can see all that in the code. We will also set up dynamic named range or define range on the tickers worksheet. So that's the tickers worksheet over here. And then we'll go to the user input form to set up a list box. You see how that's done dynamically. And then we'll go through the code for the main application. There's a lot of code, so I'll just highlight the key points. All right, so let's dive into this. So first one is to set up reference to solver. We have to go to Visual Basic and then go to Tools. References is the first one. And then you have to check the box for solver. Okay, you only have to do this once, and once it's saved, it's always saved. So I just want to show you where that button is. Okay, so you have to do that before you can run solver in the application. We are going to use solver. So solver is an optimization algorithm for linear programming. It's a built-in function in Excel. You do have to bring solver out here. So data solver, you do have to go to options and bring out solver on your customized ribbon, maybe? Not sure. Yeah. So for data, you do need, I don't know if I know how solver is brought out. You might have to look around if you don't already have solver. I believe if you take an optimization, all of you have solver on in your Excel. I've seen that in many of your machines. If you're unable to find solver, I would suggest that you just Google and find how to bring it out. So it is a built-in thing. You just have to make it available on your data tab. Okay. Sorry, I couldn't figure out on the spot how to bring that out. Mine's already there. So you have to set up solver on the model worksheet. So first of all, you have to have solver available, and then you have to go to the model worksheet to set up solver on this page. So what we are trying to do here is for the beta coefficient equation to work, what we're trying to do is to run a regression model. And the regression model is a way to minimize sum of square error. So this is the term that we're trying to minimize, although this term can be different depending on the method that the user chooses. The user can choose to minimize sum of squares, errors, or the absolute error. So that's the error term over here. Or the square error. So this is the square error, and this is the absolute error. So there are different methods, and we do offer these 4 options for the user to choose from. So what happens is that the program will choose which method will use different columns depending on the user's choices. Now, the solver program is an optimization program. We can set a target, and this is the target. The sum of square error is the term. So this is sum of square errors right now. Okay, so depending on the user's choice, we'll total up either this column, or this column. Okay, so right now the program has this, but this equation is actually generated dynamically depending on the user choice. So you will see the VBA code that controls how this formula is put together. Okay, so this number is minimized by solver, and solver will minimize this number based on changing the value of alpha and beta here. So alpha and beta are the outputs of the solver program. So how do we set that up? You go to solver, and you basically set the optimization objective to be target. The target is the range over here. So this is called target. It's right here. So we're gonna keep it as target, and then we are trying to minimize the sum of square errors over here. So it's minimized by changing the variable sales of alpha and beta. So alpha beta is a range called right here. This alpha beta is a range that's right here. So these two cells together. Okay, so that's all we have to set up, and solver will run by itself. Okay, we're not going to solve. What we're going to do is we're going to, in Visual Basic, we're going to use code to control running the solver program that's already been set up here. So when we call solver solve, it'll just be like clicking the solve button here. But right now at design time, so we are at design time right now, we do not want to run this. We just want to close the program. Okay, so what I wanted to do was really just show you how to set up solver once. So once that's set up, it's always saved, and so you don't have to do that over and over again. You only have to do that once at design time. Okay, so these numbers are basically calculated from here. Okay, and also they are sort of the numbers that we're trying to minimize. Okay, so if you go here, you will see alpha beta is the range of these two cells, and solver is trying to minimize this number, SSE, by changing the values of these two. Okay, so you will see that this spreadsheet, this worksheet has lots and lots of different ranges. So we have ticker star. Well, this is on a different on the ticker sheet. We have ticker star. On the model, we also have, say, square errors. So that is this column. We have R square. Okay, so that's this cell. So we have all these different ranges, and these ranges are what's going to be customized by the code. So VBA will come here, and actually this equation is being inserted and generated dynamically by the VBA code. So we'll see all that. So you see a lot of code that generates the formulas. So I do not want to mess up the formulas. Okay. So whenever we click this button, it'll run the solver one more time, and all these numbers will be updated. Okay. So that is the solver, setting up solver on model worksheet, and then we'll look at the tickers worksheet. So over here, we're going to see how a dynamic name range can be set up. Okay. So you can see all these name ranges, but this is actually not a complete list. This is just a list of absolute ranges. They are as it is. We've been using them. However, what you don't see is some of the dynamic ranges that we've set up for finding things dynamically depending on user input. So it's pretty nifty. So what you want to do is you want to go to formulas and then go to name manager. And you'll see that this list is a lot longer than the list that we see over here. Specifically, I'm going to show you one that is dynamic. So this one in particular, ticker range, is dynamic, meaning that the range actually varies depending on the value of some other cell. So you can see this ticker range is actually equal to offset ticker star. So we have a star point over here, And then ticker start 2. So there's actually a range called ticker start 2, I think. Maybe. Yeah. Well, so it's offset, ticker start, and then 2, and then select exchange. Select exchange is um, a variable, I believe, -1 squared times 2, and then the offset of ticker star -1, so ticker star, and then you do an offset 1. This is an offset of +2. This is an offset of -1, and then this number will change depending on the value of selected exchange. Now, selected exchange is a range, actually. Now I remember. All these little things are a little tricky to remember. So selected range is over here. Selected exchange right here is one of the ranges. So this range, this number is 2 right now because last time I ran it, I as a user chose option 2. So this value is 2. Now if I choose, and 2 is NASDAQ. If I chose New York Stock Exchange, then this value will be 1. If I chose MX Exchange, it'll be, this value will be 3. So this value is dynamically generated based on the user choices. And then this number is fed to the dynamic name range, ticker range over here to generate. So using selected exchange then will dynamically determine what the ticker range will be. So this is actually selecting the list of ticker symbols. So it's either this column or this column or this column depending on the user's choice. So if it's number 1, it will be this column, number 2 will be this column, number 3 will be this list of symbols. All right. So that is dynamic name range. And now we're going to look at how to set up list box on the form, user form. So to see the user form, we have to go to Visual Basic and see our first, we only have, we have 2 user forms. The other one is just a warning, so it's just a message. This one is a user input form that allows the user to specify the exchange. Okay, so this is New York Times or, well, no, I'm sorry, New York Stock Exchange, NASDAQ, or MX. Okay, so this combo box allows you can specify what column you want to use, what bound column. So these are numbers that you can use to specify how you want to set up where the values come from. Okay, and then this is a list box. So this list box, we actually specified that we want 2 columns. So we have 1, 2, 2 columns. And we want to be able to actually vary the value. So we have a value right now. It says Alcoa because this is the one that is being chosen. So depending on the user's choice, this value will capture the user's choice. So we'll be able to use this to determine what the user has chosen. Okay, so the value Alcoa, it's Alcoa because this bound column, so this bound column tells the list box to get information from the first column. So this is the first column, this is the second column. The value will come from the first column. So this value will come from Alcoa, will come from first column, even though there are 2 columns total. Okay. This is a radio button set. Okay, this frame that has a set of option buttons, and this will allow the user to choose one of the 4 optimization methods. So sum of square errors, weighted sum of squares, sum of absolute errors, or minimax, which is the maximum absolute errors. Okay, so this form, it's all set up, and we can see the code behind it. So this form has a little bit of code because these are all sort of event handlers that specify what to do when a button is being clicked. So you'll see that the main thing is over here. So we'll walk through this code when we run through it. Okay, so the main thing is what happens when OK button is clicked, and also when the combo box is manipulated. So we'll see how that code works when we run through the code. One thing I want to point out is that you can actually I usually don't recommend using public variables. So these are actually public variables, and these are actually useful because they become public properties of the user form object. So this is an object, and if you declare these public variables, they actually become objects, and you can just use the dot notation to access these values, and that becomes quite handy when we are working on our main application and just need to access the values from the user input. Okay, so for example, the user can specify the optimization method, weight, ticker symbol, and company name. So we store these 4 things as values, and then in the main module, which is this worksheet explanation over here, when we are running our code here, we can, if we want to know what method the user had chosen, we can just simply say form inputs dot method to access this property over here. All right, so now we are ready to go through the main application. So what I'll do is I'll just run the code by clicking this button. So we can run the code by clicking this button or this button, another on the model. Either one points to the same routine, so it's the same thing. I'm just gonna run it. Okay, so this, when you click that button, it takes you to this event handler. It's the button find beta underscore click. So this is the event click that happens when the user clicks this button. So this event handler will run this code segment. So it's a pretty long code segment, and that's really the main body of the code. So we're going to walk through this code right here. So you can see we have a bunch of variables that we use to store some essential values. We have a set of variables. These look familiar because they mimic the ones on form inputs. So we're going to use these variables to store the user inputs from the form inputs. Okay. First thing we're going to do is we're going to turn off screen updating. This can make your code run a little faster. So the code is application.screen updating equal false. You can always turn it off by setting it to true. Okay, so usually because we're running solver, which is a little bit more computationally intensive, so what we want to do is we want to turn off screen updating. We'll come back and reset it later on. We also want to turn off all the display alerts. So display alerts are just like all the message boxes, warnings, error messages, and so on. Microsoft a lot of times pop a lot of things to ask the user for input. You don't want to do any of that when you're running solver or the program. So what you want to do is you want to suppress all the prompts and alert messages while macro is running. And when a message requires a response, basically it'll just choose the default response and move on. Again, we'll turn this back on when we're done with the macro. We'll get some user inputs. So for we're gonna set up the form input. This form inputs, it's gonna show, and then we're gonna get the ticker variable is the variable we dim in this program. We're gonna get form inputs dot ticker. Remember I talked about how you can just use the dot notation to access this property of the input. These are the public variables from this form. Okay, so let me go through each one of these. Okay, so we're going to show, and then when we try to show the user form, the initialize event handler will set the list index to 0. This will fire the the combo box. So this is the combo box. Okay, the combo box will fill in the ticker list now. So let's just do that. So when the combo box is being changed, this is because this code is triggered when the combo box being changed. So that's why we just did something. We set the list index to 0, which affects nothing, but that triggers this change event handler, which allowed this code segment to be run. So in this case, we're going to see what the combo box is being selected. So right now it's NYSE. So in the case of NYSE, it's going to set the selected exchange, that is the yellow highlight value of this one. This value is going to be changed to 2. Okay. So, and then this dynamic ticker range is a dynamic name range that varies depending on the value of selected exchange. So selected exchange, this cell, the value is 2, so we'll just put together this address, ticker symbol, because the ticker range is put together based on, ticker range is a dynamic name change. So in the name manager, it'll put together the ticker range address based on selected exchange. And now this address is this, you can see. The address is D4 to E96. So those are the 2 columns for New York Stock Exchange. So D and E. And those will become the row source for this list box, list tickers. The row source will come from the source of the list box information for the tickers will come from the 2 columns for New York Stock Exchange. Okay, so it's a pretty sort of nuanced way of running the program. So now we are showing the form, and you can see New York Stock Exchange is being shown, and the list of companies for New York Stock Exchange are being shown. Now I'm going to change. So right now it's Alcoa. I would like to choose a different company. So I'm just going to go down the list and choose something else I like, maybe Promoter. Okay. And then I can choose a different model. So when I click this, you know, Minimax, there's the event handler. It'll turn off the weight, because the weight text box is only enabled when you choose the weighted sum of square errors. So since we did not do that, we chose Minimax, this text box is disabled, just to prevent the user from clicking on it by mistake. So now I've chosen my company, I've chosen my method. I'm going to click OK. And when OK is clicked, this code segment is going to be run. So we'll go through this now. Okay, so the ticker, the list box. Okay, right now the value is for motor because that's what I selected. And so the dot list index right now is 38. Okay. So if it's -1, that means the user did not choose a company. We're going to ask them to choose a company, but because I did, and that's Ford Motor is number 38, then we're going to set bound column. So bound column means that we get the information from the first column. The company name is Ford Motor, so that's from the first column. Bound column 2, so now we switch to column 2 as our value source, and now the ticker symbol is the value of F. So that's the ticker symbol for motor. Okay. And then we capture the method for using in optimization or the solver program. So I'm going to say solver. So select case, we're going to see. This is the sum of square error is not selected, so it's skipped. weighted sum square is selected, is skipped. Sum of absolute value is error is skip. We did choose minimax, so the method is now set to minimax. And then we're going to hide the user form because we're done with it. Okay, so now we're going to go to the company name is Ford Motor, and the ticker symbol, the range of selected company name value, the selected company name. So that is, if you go to ticker, so selected company names right here, Alcoa. This is the selected company name range. Okay, so we're setting this range, this value to Ford Motor. So right now it's Alcoa because Alcoa was the last company I used. So now after we have executed this, you come here, the cell has been Ford Motor. So that's consistent with our understanding of the code. So if the ticker has changed, so the ticker is F, the previous ticker value was AA, so Alcoa. Since these two are different, then we're going to set the new, the value, to Ford Motor, so F. And then we're going to go to the stock. So we have a stock worksheet. So this worksheet was labeled AA because it was Alcoa, but now we're going to change it to ticker. So we're going to set the name of this worksheet initially. Right now it's AA. We're going to update it to F for Ford Motors. And then we're going to clear old data. If there's any data on this, we're going to count the number of rows. So it's 101. The number of columns, we're going to count it. It's 6 columns, and if the rows is greater than 1, that means we have data. We're just going to clear everything. So this is the clear content. It's coming in, and we're applying it to all the rows and columns on this worksheet. And then we're going to go get the ticker data. This is by using an API. Okay, so the we are going to set the application status bar, which is the status bar at the bottom over here. So you can see running web query for F. So we're just telling the user that we're running query for F for Ford Motor. And then that's just the nice little status bar of this application, okay, that we display for the user to see. And then we're going to do a for loop. We're going to run. We're going to try to connect to the API. And we're going to do this until it's successful. So what we're going to do is we're going to do a do loop. It's while not successful, we're going to continue to try until it's successful. So initially, we assume it's successful. And then we call the run query. So run query is right here. It takes these 3 input parameters, and it'll tell us whether it's successful or not. If it's not successful, okay, so if successful is false, then we're going to do error message. We're going to abort, retry, or ignore, right? So we're going to do a bunch of things if it's not successful. If it's successful, then we're going to end. Okay? So this do loop will end when run query is successful. So we're going to go into run query now. Okay, so run query takes ticker symbol, which is F, this worksheet, okay, and successful, which is true right now, as Boolean, and we're going to run with this worksheet. We're going to say that we're going to get the stock data. So we have a key to this API. So the key is stored in this hidden worksheet called my key. So my key is hidden over here. Let's unhide it. You can see that it stores only one thing. It has this code that we have obtained for accessing the API. Okay, so this is, we're going to get this value, which is that key, and we're going to store it in this variable called my key. So now my key has this value, which we can use to run this web service. So worksheet function dot web service is just a way to access the API at this address. So we have the address of the API from AlphaVantage. Okay. And then what we do is we just have to format this so that we have the ticker symbol as part of the URL. So the URL is this function equal times series daily and symbol equal, and then this is a variable. Ticker is F, depending on what the user had chosen. Since I chose Ford Motor, ticker now has the value of F. And then we have the key, and then you do API key equal, and then my key is a variable, has this key that we need, and data type equals CSV. So we're requesting for a CSV file from this API, and this entire CSV file will be downloaded as long as you have a successful internet connection, and if the key works, which it should, then we should be able to get a CSV file of all of Ford Motors daily time series data from AlphaVantage, and that entire CSV file will be stored into this text variable. So this text variable has a lot of stuff in it. So I'll show you, hopefully we'll be able to see it down here with the text. Okay, so you can see this text string is very, very long, has lots and lots of stuff in it, has the timestamp, open, high, low, close volume. So it has tons and tons of it's just all the numbers that you need for. So you do need to go to the API. So if you go to our page, you'll be able to see there's a link to AlphaVantage's API documentation. You can read about how the CSV file is formatted. Okay, so there's a lot of documentation on that. Okay, so basically that's the CSV that we have downloaded. It's downloaded into a single string variable, which is kind of crazy, but that's how it's going to work. Okay. And so we're going to check if there's an error message in the text. Okay, so if there's if we see error message in the code anywhere in the string variable text, then we're going to do something to handle the error. Then we'll say success is false, but we don't actually have error message. So that means we have successfully downloaded the CSV into the this text variable. Okay, so we now turn off the display alerts again, and then we're going to determine how long the CSV file is. It's probably very long, so we're going to do a length. Okay. So the length is 4964 characters exactly. So a fairly big string variable. And so these are just some sort of variables that we're going to use to process the data point. The position, POS is really the position in the file. So we're just going to start with 0, and then we're going to move to the first character. We're just going to read one character at a time from this text string. So we're going to do a do loop. We're going to do this until we hit the end of the text. Okay, so we're going to move to the first character position in the text because right now it's 0. So what we do is increment it by 1. Okay, starting with the first character. And then we're going to process the subtext. Right now, we're going to set up a subtext that is just a blank. There's nothing in it. And then we're going to start appending things to the subtext. Okay, so the subtext is going to be taking the entire text string, which is 9,000 some characters. We're going to take start at the mid is just taking the middle portion of the text. But this is really the beginning because we're starting with position 1 and we're just taking one character. So this is just saying, go take the first character of the text. And the text starts with timestamp. So the first character should be T. So we'll see if that becomes T. Okay, so the subtext is now T because it's getting the first character of this text. So position 1. okay? And we take one character. So that gives us exactly one character, which is the character of T. And then we're going to move the position to the next position so we can read the next text. So now position is 2, and we're just going to loop until we do not see the end of line. So VBLF, this is line fee, which means the end of a paragraph, and we're changing to a new paragraph. So so that usually means the end of the file, because this is just a giant one-line CSV file of stock data. So we know when we see line fee, we know it's the end of the file. Or if the position is greater than the length of the file, so the file is, oh, it's only 4,000, not 9,000. So it's 4,900 characters. So if a position is greater than the length, that means you're going beyond the scope of the file, and that means you've hit the end. So you want to end this do loop until you are done. Okay, so you're basically going through this to get the subtext. Okay, and you keep appending the subtext. So the next point is getting the subtext now is TI, and the next time around the subtext will be TIM, right? So you just keep adding a character, another character, another character. Okay, so when you hit the end of, oh, so this is the end of the line feed, not the end of file. So once you hit the end of line, then your subtext is done. Okay, so this is the subtext is one line. So let's put a star over here, a stop over here, and see when we can get out of this loop. Okay, so we're out of the loop now, and we can see the subtext is timestamp open, high, low, close, volume. So this is basically the CSV file, the heading. So the first line. So this subtext is really we finished reading the first line. So we read one character at a time until we hit line feed, which is the end of line. Then we have gotten the entire line, and the output line right now is 1. So we keep track of which line we are at right now. Okay, so if it's greater than 1, okay, which means you're the second line and so on, then it's data, and we'll store the data into the spreadsheet, the worksheet. But if output line is first, that means it's heading. So right now it's heading, so we're just going to skip it and move to the next line. So so now we're going to move on to line 2, and then we'll just continue to do this as long as we do not hit the end of the file. Okay, so now we are moving on to the second line. So output line is really the line count. Okay, position is the number of sort of character position in the current line. Okay, so now we move to the next position. Okay, so now we move to position 39. Well, actually, it's the character position in the current, well, in the CSV file. So it's a giant CSV file. It's actually considered a single line, and this is just line count per VB line feed. Okay, this is a little tricky to understand because line feed is a character actually. So you technically do not see any sort of visible line. It's a giant one line text file, text variable. However, we're counting a new line by this VBLF character. It's called a character. It's not an actual line change. So we just go to the next one. So what we're going to do is we are reading our next line. So now we can see the subtext is the second line now, and it has a date, right? April 22nd, that's today. And then we have the open, high, low, whatever, all the column data. So you can actually look at the headings and figure out what these numbers are. So once we have these numbers, And the output line now is 2 because we're looking at second line. Then we are printing the data. So start data. So this is the dot range. We are going to the tickers. Well, we're going to the unhide the 4 motors data. So now we're printing all this. High, open, the timestamp, open, high, low. These are data from this current line. So we are printing both. So we have printed the close and the volume. Okay, so this is the printing portion. And then we'll go to the third line, and then we'll just continue to run. So this is the third line. So this subtext is April 21st. So we're actually reading 100 days of data. So we'll keep doing this. You'll see, you know, going backwards, starting with today all the way backwards. And we'll do, once we finish, we'll be able to have, I think it's 99 days or 100 days. Not sure. Okay. So we'll just continue to run through this until we are done. So we'll do this. I'll remove the stop. All right. So this is taking a while because it takes a while to read all the data and populate the spreadsheet. So now, see how beautiful this is. Populated the entire 4 motors spreadsheet. Okay. I believe that's also populated the S&P spreadsheet. Let's go take a look. So if we unhide, we can see the S&P. This S&P has also been populated using today's information. So this is the most recent. And then we're going to run solver. So we already set up solver on the front end on the spreadsheet. So what this line of code is just to ask solver to solve using what we already set up at design time. And this is basically equivalent to clicking this is equivalent to clicking the solve button on the solver interface. So we'll just run this. It'll run solver. And this is the solver sort of dialog box. We can, it may be a little confusing for the user. You can actually suppress that. I'll show you how to do that. So the beta has been calculated. It is for this period is 1.367. You can click another button to repeat it for different options. So we are actually done with the program. So if you go to the model, you'll see that we now have Ford Motor as the selected company over here. And the method is minimax, which is what I chose. And this number was actually minimized, minimax over here. This number was minimized based on my choice. This is what solver did. So solver got this minimal number by altering alpha and beta. So these are the best numbers to minimize this value, this optimization objective function. Okay. So the reason why we got that solver dialog box is because I set this to false. Now, if I change this to true, then that dialog box will not show up anymore. So that is all. So I think there's a lot of different moving parts for this program. You might want to kind of explore around, look at different code. I don't know if I overlooked anything. I don't think so, but this is a big program, so you definitely want to take some time to explore it. Oh, this enter formulas, we didn't even go through this, but this is how all the formulas are set up on the model spreadsheet, like all these formulas. So depending on what you have chosen, these formulas will change a little bit based on the user input. Okay, so all these formulas are set up based on the method, SSE, WSSE, sum of absolute errors and minimax, and then the model will set up the errors, square errors, and absolute square errors of these different columns based on the data. So the regression line is alpha plus beta plus, the cell in the same row and two columns left. So RC -2 is basically the same row, but two columns to the left. The -2 is going left. Okay, so that is setting up these columns and their formulas. And this is setting up the error column, is setting up the square error column, setting up the absolute error columns, and so on and so forth. So all these are dynamically generated. Now, if the method is weighted, then you will actually have to add the weighted function over here as well. So the weight, you basically take the value and then time the weight over here. Okay, so that's why we need this, because the different methods will require slightly different equations. Okay, so this is also dynamically changing the target function. So the target is the yellow highlight, the number that gets minimized, this number. So this number, the formula for that will also change depending on what method was chosen. So this is the target and the target cell. Okay, so we have slightly different equations again for different methods. So again, a lot of details. I encourage you to explore how these formulas are set up. So you can see these are all sort of sum of square equations for the regression model. So to understand these equations, you really have to understand regression and sum of what errors mean. It's basically the difference between prediction and the actual values. Okay. So that is all. Enjoy, explore around, and bring your questions to the office hours. Thank you.